Well, hello there and welcome back to Cool Bitcoin. I'm here to show you some more cool and really, I'm really sorry for the previous stream because it seems like the audio was not functioning properly. There's always this issue with the sound card. I need to restart the computer for it to work. And I hope it's fine now. If you're watching this or you're listening, give me a confirmation somewhere. Let me know that this works. What we're going to do today, and it kind of sucked that I lost like 20 minutes of talking and I've been talking to myself. You guys haven't heard me. But what we're going to do today is to create a new wallet in Bitcoin Core, as you can see right here. And then we're going to use this wallet to receive some BTC, and then we're going to follow the next important function in running your own node, which is using it. And in order for you to use it, you need to have a proper backup. And that's the most important part, as it gives you the guarantee that your funds are there. And if your computer breaks, you're going to be able to recover. For that purpose, we're going to use an SD card, which is, I guess, unusual. Most people are used to some sort of BIP39 seed phrase or hardware wallet or whatever, but Bitcoin Core works with wallet.dat files. So you're going to export the backup of a file, preferably in external storage. For this, I have an SD card, but personally, I recommend that you use a spinning hard drive, an HDD, as these are proven to last over decades and are less likely to fail and are easier to recover, whereas this one breaks more easily. But I'm going to use it just for the purpose of this demonstration. If I were to recommend you some sort of storage to keep encrypted backups, hard drives are so much better. External, internal, you get to choose, but it's preferable that they're not permanently connected to your internet computer. So with this being said, let's proceed and create a new wallet. And then I'm going to show you all the steps involved. Right now, this is Bitcoin Core. It has been synced, as you have seen in the first episode of this series, from the Genesis block, but it's also a pruned Bitcoin Core node, which took 24 hours to sync. This means that I did download every block from Genesis until today, but the older blocks, the ones that, how should I put it? So I only have 6 gigabytes worth of data, worth of transaction blocks from the Bitcoin blockchain. Whenever a new block gets mined, an older one gets deleted from my storage. And this is for economic purposes, and that's because most people most likely don't have almost 500 gigabytes on their computers to keep everything running. So this is very convenient. You just keep 6 gigabytes. It takes a while to sync, but after you sync, it's not enough to only run this. You must use it for your own sovereignty. And now we're going to create a new wallet. We're gonna call it Cool Bitcoin S special characters T. It's supposed to be actually, but you know, I'm trying to be family friendly right here. I'm also going to encrypt it. I don't want to disable the private keys. This is a feature that's only good for watch-only wallets. I don't want it to be a blank wallet. And these are the perfect settings. External signer would be for a hardware wallet if you're using PSBT for that. And we can talk about that in a different episode of the series. But for now, we are just creating a wallet. And after you do create the wallet, you have to set a passphrase. Why do you set a passphrase? Specifically because in this step, so when I did click create a new wallet, I picked the encryption. So the passphrase is your encryption. Let's write CBS once again. BS, you get it. And now I have to type a passphrase. The recommendation from the Bitcoin Core developer is that I use 10 or more random characters or 8 or more words. I'm gonna try to write a phrase that I can remember and that I wrote down in a notebook. If you're watching this before it was not working, No, before it was working. So, like 30 minutes ago, I tried to do the same and I wrote down everything in a notebook. If you don't trust paper, you can use something like the Bill Fuddle, which is made by my friends Colin and Brian. They have this business with metal plates, and metal has the advantage that it resists floods and fires and physical damage. So if your biggest enemy is the weather or Mother Nature or the will of God, then one of these makes sense. But if your threat model involves people coming to visit you, you need to hide this from their sight. You don't want them to see it, so it's a lot harder to hide a bigger metal plate, which looks distinct and has proper logos on it to differentiate it from anything else, or a hardware wallet, as opposed to having a piece of paper. A piece of paper is something you can put inside a book in your library. And you're going, most likely, unless you have lots of readers who come into your house and randomly grab books from your shelves and read them, which is unlikely, but you're going to have a lot, you know, a more easy way to hide your passphrase. And this passphrase, as I said, I'm gonna use a phrase that I know. This is 33 characters, I counted. I mistyped. Okay, so it seems like the amount of characters is equal, which supposedly means that I have no typos here. I wrote this down on a piece of paper. If I want to keep it in cold storage, I will also put it in a metal plate. I recommend that you use whatever fits your purpose. But in this show, I try to explain to you stuff that's free. So I guess everyone has a notebook in their homes. Everyone has a pen. So you just write down and figure out later if you need to also do a metal backup. I click OK, and it says warning, if you encrypt your wallet and lose your passphrase, you will lose all of your bitcoins. This is very important to keep in mind, that security is good, security is useful, but you must also secure stuff against your own human flaws and your own degrading memory. You should not rely on this because it's going to degrade over time. You never know when you hit your head or something happens to you and you no longer remember. Don't rely too much on your memory, but at the same time, don't rely too much on single points of failure, like backups on some sort of agenda or notebook. Be cautious and do something that you are sure, you are certain that you're going to remember at any given time. So it asks me if I want to encrypt the wallet. Of course, I want to. Your wallet is about to be encrypted. Remember, oh, fuck up. I said this is going to be a family friendly show, but I said the F word. So, off Bitdefender. I don't want to pay another license to you. So, the wallet is about to be encrypted. Remember that encrypting your wallet cannot fully protect your bitcoins from being stolen by malware infecting your computer. This is also important. So, if you have malware in your computer, it can steal the files which store Bitcoin Core. But at the same time, they can access your wallet, but they cannot spend it because they need this passphrase. Unless you also have a keylogger, so that's extra, I guess, extra complicated. If there's software which basically stores all of your passwords and sends them to some sort of server outside, then you're gonna be in trouble. But right now I have zero balances and I can get to show you how to use this wallet. And you can't really use this wallet if you have no transactions. So for this purpose, I'm going to receive some funds and let's see if, yeah. So Let me hide this for a moment because I want to send some funds to myself and I need to do some settings to tweak. So where is it? It's this one. Okay. So what I have here is Wasabi Wallet 2.0. And I have some UTXOs, I hid them so you don't get to see the amounts. And I guess you also get to see how you send stuff. So I go to send and I pick the recipient, and in this case it's gonna be myself. I'm gonna do a self transfer. I create a label, I'm gonna call this episode 4, so I remember when I did this. I don't set a specific amount. I can even choose a taproot address, but I don't think it's supported by Wasabi yet. So let me create this. I copy the address. And it's important to always look, so don't rely on your clipboard from your OS because this can be compromised. Keep this on, and something that you should always check is like the last 5 or 6 characters. So in this case it's SHYX5WQ. So let me paste this here. It's SXYX5WQ, so it's the correct address. The first few characters are easier to forge, to mine, using a powerful computing processor, but the last ones are the most difficult. So that's the reason why it's almost impossible for somebody else, for an attacker, to figure this out so fast, to create it. So if the last few characters from your address are correct, it means that the rest of it must be correct. It must check out. And the amount that I'm going to send for the purpose of this video is $21 in BTC. In advanced options, I'm going to set the fee rate to 2 base units. I'm going to continue. I need to name the recipient. Maybe I'm gonna call him the Pope, because that's what I call myself with the lights out. So I get to confirm one last time. This is the Bitcoin amount. This is the address. Once again, it's SHYX5WQ. So I know that this is good. And I also have the transaction fee right here. And I confirm it. Now, oh yeah, I also need to type the passphrase, which is separate for Wasabi. So I did all of this to send some BTC to myself. Because it makes more sense to back up this wallet now that it's going to have some Bitcoin on it. In the overview, as you can see, it already caught the transaction. It's unconfirmed, it's still in the mempool. But I have a pending balance, that's right here. And this is going to be worth a lot of money one day. So let's watch it on... Actually, let's not use a blockchain explorer. Let's use Bitcoin Core because you're supposed to use your own tools. This is the transaction ID. I copy the transaction ID. I go to the window and I go to the console. In Windows, it's Control+T. And here, let's get transaction. You also get suggestions, so let's play with it. Get transaction output. Now I'm gonna paste the transaction name. So I have all of this information about it. Get txout transaction ID and N. What's N? Include mempool. Returns details about an unspent transaction output. Arguments are txid, which I already have, this string of letters and numbers. And this is S, numeric regulated vout number. Include mempool, boolean, optional. Default is true, whether to include the mempool. Note that an unspent output that this is spent is in the mempool. Okay. Results if the UTXO was not found. So basically I'm getting information here about how to use this. So I'm supposed to write the transaction get transaction output. Where is it? Get TX out. And I have to write this in quotation marks. What I'm trying to do here is what you get when you go to your internet browser. You open something, so Firefox updated. You open something like mempool.space. I keep on pressing caps lock instead of A. I'm not used to this keyboard. You go to mempool.space and you paste the information about the transaction. And you can see that it's here in the mempool. So it's going to be confirmed soonish, I guess, since the mempool is almost empty. But of course, this is a nicer interface which uses somebody else's node. If you want to be 100% sovereign, you should learn how to use your own tools. And in Bitcoin Core, you can use the visual tools. So you have what you see. Let me close this first. You have what you see here, which gives you clear information about what's happening with the transaction. It says unconfirmed in memory pool. It gives you the date. It tells you that it doesn't know who the sender is. And it tells you about the amount, which is $21 at today's rate. This is the transaction ID, transaction size, output index. Okay. So we are here because we have received some funds and they're going to be confirmed in a future block, maybe in a couple of them. And what we want to do is back up the wallet. Something important that you must do in Bitcoin Core is to go to File and choose Backup Wallet right here. And now it opens your Explorer as to where you want to save the file. And as I said previously, so I did create the wallet, I did encrypt the wallet. These are two steps that are important, but it should not only exist in your computer. So you should also put it on some sort of external storage, preferably that you don't use for anything else. So I'm going to insert this SD card into my laptop, into the Windows laptop, which is used for so many of these presentations and demonstrations. I keep on missing the port. Okay, now it's in. I have some pictures on this SD card, but for the purpose of this, I'm going to create a new folder. I'm gonna call it CBS Backup. Of course, cool Bitcoin stuff, as you can deduct from the context. That's what it stands for. And now let's grab this and back up the wallet. I'm gonna want to go to this external hard drive, CBS Backup. I can name it. It's gonna be a wallet data, so .dat file. I'm gonna name it CBS4 because it's the name of this episode. And I saved it. I pressed enter. Now it's saved on my storage device. So let's find it. You can actually close Bitcoin Core at any point. You don't have to keep it on while you receive a transaction for it to get received. That's the miner's work right now. Your node is like the receiver and the transmitter, the broadcaster of information. It's still unconfirmed, but it's still an amount of BTC, right? So you should always make sure that you take good care of it. And for that purpose, so I have 0.01 BTC. At today's rate, that's $21. So you should take good care of it. Maybe one day it's gonna be like 100x more. Maybe one day it's gonna pay for your child's college tuition. So I did close Bitcoin Core on purpose because I want to go back to this, the SDSC. I have the cool Bitcoin stuff backup, and it's a dot file. dat. Windows has no idea how to open it. Of course. And this is how you open it. I just showed you that you must point the file to the right application to open it. In this case, I chose Bitcoin Core. So Bitcoin Core doesn't use BIP39. BIP39 is a standard that lets you encrypt your, or compress, more like compress your private key in a humanly readable form. If you want to learn more about it, you go to the BIP39 dictionary. And this is what it is. For English. So if you create a new wallet with something like Wasabi, something like Electrum, something like a hardware wallet, you're going to get 12 or 24 words from this list. And all of them are made in such a way that for every sequence of characters, you have at least 3 or 4 options. For example, if you type in DA, you're going to have lots of options from dad, damage, damp, dance, danger, daring, dash, daughter, dawn, day. You have all of these options, and it makes it easier for you to not type the entire word. And this is good against keyloggers, against software that's going to tap everything that you type. Maybe you type DA and it's dance, and you're going to pick it from a list. That's the way it works. And then you have the rest of the words, which are 12 or 24. And the number of combination makes it nearly impossible for someone to guess. If you think about it, it's like 1 in a few million times odds for someone to guess based on just having the first couple of characters of every word. There are way too many combinations, and you need all of them to be correct to hack into your wallet. But if you also add a passphrase on top of it, even if someone knows everything about your wallet, they still cannot access your funds. They cannot spend them. The same can be said about Bitcoin Core and this wallet file. So someone can open this on a different computer. Someone can hack into my device or steal my SD card and find this and try to steal my funds. They cannot open this because it's encrypted. And encryption means that you need that specific passphrase to be able to access the funds. So this is a very important part of your sovereignty. Encryption is a powerful tool that helps you take care of your data. But encryption in this case is guaranteed by your passphrase And if you ever lose that passphrase, it's bad news because nobody else can recover it for you. It's your own responsibility, and as you know, you can never have freedom and sovereignty without responsibility. You're supposed to embrace this with utmost carefulness and never let someone else know too much about your backup. In this case, I've only made a demo. I sent about $20 worth of Bitcoin to a wallet. It's still pending, it's not confirmed yet, but this is one of the cool functions that you have in Bitcoin Core. And you're supposed to use your node. That's something which gets understated. Everyone is going to bully you into running a full node. They're going to be like, no, you're supposed to be sovereign. Stop using somebody else's node. Run your own from home. Get a Raspberry Pi with Umbrel or whatever and run it. And people do that. They spend a lot of money to get a computer that's going to sit idly in their homes and they're not really going to use it. And that's a shame because you're not really helping the network. And the point of running a node is to help yourself. And if you can't help yourself, then it's kind of pointless. So try to use the node that you have. In this case, I have an instance of Bitcoin Core, which pairs very well with Wasabi. So I always use these two together. And since we are waiting for this transaction to confirm, let's take a look at what it looks like on the public blockchain that I sent this. It seems like it's not gonna be in the next block according to the math being done by the mempool folks. If you want to learn more about the mempool project, I actually have an interview with Simon, who's the creator, and it's on the Bitcoin Takeover podcast. It's season 11, episode 1. Go check it out on Spotify, YouTube, whatever you choose. This is what the transaction looks like on the public blockchain. I have one input and two outputs. This is actually the input that was used from Wasabi. And I have this one, which was sent to myself, which completed the transaction, and this one which returned to the wallet. This is the most basic type of transaction that you can have. And now if I go back to see what's going on with this address, I'm gonna see that, okay, it was part of this huge coin join. It has 116 inputs and 192 outputs. And this is kind of insane. This is why I like Wasabi 2.0. Basically, you don't know who is who and which transaction belongs to whom. The number of inputs is this, and you can see that they have different sizes with people joining, and these inputs got combined. This is how coin joins work. You have the same amount for multiple people being exchanged in a way that makes it hard to figure out what's going on. If you are this guy who spent most money for this coin join, who put 2 BTC, then you're going to have, I guess, the largest number of combinations. It's likely that you're one of these free guys, so this is one of yours, 1.3421 blah blah blah. But then again, there was also someone who had this exact amount. So the number of suspects in this case is 4 outputs. So you're going to need further coin joins to make this really private. But as you walk down and scroll, you're going to figure out that, okay, this guy who entered with 2 Bitcoin actually has 0.637 whatever. 0.7, let's round it up. 0.7, so that can be any of these. Like it can be one of this combined with one of these combined with one of these, and it just gets so intricate. If you are, I guess, one of the smaller contributors to the coin join, so if you are this guy joined with the smallest amount, which is 5,000 base units or satoshis or 50 bits, as I like to put it. So if you are that guy, Wait, let me move my own face. So, no. Actually, this is good. So if you're that guy, you only have three possibilities. So your anonymity set and plausible deniability is smaller if you are the smallest contributor. But it's still interesting that you have 4 people with 5,000 and you have only 3 inputs with 5,000. And it's likely, I don't know, maybe that some of these got merged together, became also inputs right here, as you can see. And something happened, some sort of combination magic to make this. So I guess the person who had only 5,000 base units also had another one of these inputs, and maybe that they got combined and then mixed, and something happened there, and it's very hard for the software or anyone who observes the public blockchain to understand what happened in this situation. Maybe it sounds complicated, but I still find it fascinating. It's been like 2 weeks since Wasabi launched this, and there's a lot of work that they put into it. And you can tell that they're making privacy a lot more accessible. And look at all of these outputs that were derived like extra from the inputs. It just goes to show that they have maybe the best math for privacy right now. And I'm not saying this just because you can see their logo up there as they're sponsoring my podcast and I gotta praise them. But they actually did a good job. As before this, the coin joins had an equal amount of inputs and outputs, and all participants were using the same amount to be able to form a coin join. That's no longer the case. They figured out how to divide amounts in such a way that everyone is going to have more outputs. And this is also more scalable than it was previously the case. If you talk to Yuval Cogman, I think that's his last name, he is the guy who invented Wabi Sabi. So he is like the mastermind behind this type of coin join. He's going to say that his vision was not respected all the way through and he thinks this can be better. And this is kind of mind-blowing if you think about it, because you can criticize and say, okay, this is not even the final form, but it's only gonna get better. Now I'm enthusiastic about this. So yeah, my transaction comes from this string of transactions, and it's tricky for anyone to figure out which one it is and that it belongs to me. The only giveaway is that I actually made public in this video the transaction ID. And by the way, there was a miner who put my transaction into a block. So I got lucky. It was from Foundry USA. Right now I have an extra reason to pay more attention to the backup. As you can see, the node actually confirmed it. So you get this visual information from your Bitcoin Core wallet. I have one confirmation, but the core developers are more conservative and they recommend that you wait for at least 6 transactions before you decide that this was final. You can set this, I guess, somewhere here. You can even spend on confirmed change, which is not recommended, but whatever. It's your threat model, it's your financial sovereignty. You are the one who's in charge of this, and you know better than anyone else what kind of sovereignty you need. So yeah, I guess I did fulfill the purpose of this video. I showed you how to create a wallet in Bitcoin Core. I showed you how to encrypt that wallet file, and I showed you how to save it, and then I received one transaction, and I showed you what Bitcoin Core tells you about that one transaction. If you're like a wizard who knows how to use command line here, you can get basically in text form all of the information that you can get from a mempool visualizer. So it's convenient to use this. I think it's even better to use the Tor version because that doesn't log your IP. But still, if you are not comfortable with the fact that you type this and maybe that there's a server which stores your query and knows that you searched for this from a certain IP and the IP is associated with your location. So if you're not comfortable doing this, you should learn how to make use of the command line. And you're supposed to get transaction output. And there's something wrong about my syntax. Maybe that I will get it right for the next episode, as I don't want to spend time reading this from top to bottom. But I should have something like get transaction output, transaction ID, and N. And N is the numeric. What's this? Vout number? V out. So let's try again. Get TX out. No, I did not mean to. I typed this in quotation marks and the number is 1. So it says right now that the best block is this one. It's confirmed once. It has this value. It has this script public key. I even have more information about the address in multiple formats, hex and descending, I guess, DESC. And Coinbase is false. Coinbase is not the company. Coinbase is the reward that goes to the miners. So most miners also run their own node. And if it was part of the Coinbase reward, then this would be true. But in my case, my transaction was just a regular one that was included in a block. It was not part of the monetary policy of the Bitcoin network, so this is false. But I just showed you that you can basically see the information. So this is the name of the block in which it was included. Let's see if it checks out with the name of the block here. 743354. It's not like this. I'm supposed to look for, this is the hash, I guess, which mined the block. Yeah, so it ends with 29E5790. Yep, 29E5790. So I got the cryptographic hash that the miners found to discover this block. Now let's see what happens if I type get TX out. I type this in brackets, not brackets, quotation marks, and the number is 7. It says null because I have this extra argument which is called the N, which is the V out number. I guess there are not enough blocks that have been mined in the meantime. So if there were like free blocks, I could write a free and I could see the latest free blocks and information about them. But since there's only one, only a command with the number 1 works. Otherwise I get a null return. See? So if you're good with command line, you can use Bitcoin Core to fulfill all the purposes of the regular blockchain software. We should also look at blockstream.info. Let's see what happened here, because they have some analysis. It says that the transaction doesn't violate any of the privacy gotcha that they cover. So this is good. But if I go back to this one, you can see that it was this output from this humongous coin join. And if you scroll all the way back, it says it was possibly a CoinJoin transaction. So this is also something that, oh, so you're not seeing it. Sorry. So this was possibly a CoinJoin transaction. So yeah, you should be aware that CoinJoins are visible, but at the same time, if you see this huge difference between inputs and outputs, you're gonna figure out that, you know, good luck guessing anything that's going on. Anyone, I guess the more Bitcoin you put in, the more non-sets you have, but anyone can virtually be anyone else. And I guess the guy who gets the least amount of privacy is the one who contributes with the absolute smallest amount here, because you get equal outputs, and you can say that this guy, maybe that you don't know anything about him, but this guy right here can be any of the three on this list. So it's easier for you to narrow down your search. But if you are maybe, let's find a somewhat bigger one. So this guy, 000065536. I mean, you can be this guy combined with this guy, combined with this guy, combined with this guy. So you can have 4 outputs in this CoinJoin. So if you do another one, then it's gonna be even more obscure. And it's kind of a pity that this comes at the expense of occupying precious block space and paying transaction fees. But it is what it is, you know, because we don't have privacy by default in Bitcoin. We have to create it ourselves. We have to make it work as money, because that's the whole point of privacy. We're trying to create privacy in Bitcoin because we don't want third parties to discriminate between one input or the other. We actually output UTXO. So we want them to consider one Bitcoin to be equal to any one Bitcoin, not this Bitcoin comes from Silk Road and this Bitcoin comes from Coinbase. So I'm going to deny you access with the one that was used on Silk Road in 2012 and only accept this one that comes from Coinbase and was mined in 2020 or whatever. So it's an important problem that needs to be solved, and I'm trying to push it as hard as I can and tell people that they should care about their privacy, as this is like a glass house. And if you KYC your BTC, then some company is going to know what belongs to you, which means that your government is going to find out what belongs to you, and all of these blockchain analysis companies are also going to know. And I don't like the idea of a future which is very much Orwellian, and where you can know how much money your neighbor owns, you can know how much money anyone else owns just because it's public, it's out there. Even banks today have this privacy policy which only lets maybe your government or whatever know. If it's a Swiss bank, I guess you get better treatment still. But how many of us have actual access to Swiss banks? Anyway, Bitcoin Core is very underappreciated and underrated. There's so much that you can do with this. For example, I can look at peers or whatever. I'm actually connected to someone using Wasabi and a few people running Bitcoin Core. There's someone who's using an older version of Bitcoin Core, 0.18, which is like 4 years old if I'm not mistaken. But this is the beauty of BTC. You run your own node and respect the rules that you want. Nobody can tell you what you can do with your money, and you are responsible to take care of it in the best way that you can. There's a lot of cool stuff here. There's a lot of cool stuff that I want to show you in Bitcoin Core. I guess the next one is going to be following the logic of features here. I guess it would make most sense to... So let's close the wallet. This is also important. Mm. So I did close the wallet, and I'm going to open this wallet. I do have it. So it did open with the wallet.dat file. But if I try to send, let's say that I generate an address here in Wasabi and I want to send it. I just want to show you that I need the passphrase. So I want to receive from John the Baptist. I have this address here which I am copying, and I'm going to paste it here to make the payment. For the amount, I'm gonna use the entire balance. And then let's choose a slightly bigger fee. But this makes no sense. It's not so important right now because I'm not really making a transaction. I'm only showing you that if your wallet is encrypted, you're gonna have to type the passphrase. There you go. You cannot make transactions unless you have the passphrase. You can see the balance. You can do some basic verification stuff about the wallet, but you cannot touch the funds. It's gonna ask you to type your passphrase because it's encrypted. That was the whole point. That's why I made it encrypted. And this is what I wanted you guys to see. That passphrase actually matters. In the meantime, another block was mined. I have 2 confirmations. At 6, it's gonna be considered final. You actually have some nice pie chart here, which shows you that you need 6 confirmations, which are recommended. It's like 1/4 right now, a quarter that got filled. At 3, it's gonna be a half. I guess it's not the best representation because it's gonna become a half very soon, but still, really interesting, useful, and free and open source, and the most tried and tested Bitcoin wallet out there. So I can't really recommend Bitcoin Core enough. I know it sounds too good to be true to some extent because people expect to pay for stuff. They buy Windows because they think it's gonna offer them at least support and whatever. But there are so many cool Linux distributions that offer you so many features and are more robust and stable and more tested. So yeah, Bitcoin Core, I can't praise it enough. You should get it on a computer. If you have an older laptop, you should consider wiping it and using it for Bitcoin Core, and that's gonna serve you well, I guess. It's kind of your ultimate sovereignty machine. It's something that you run by yourself and for your own financial sovereignty. I'm using a Windows laptop specifically to make this demonstration, but you do whatever, figure out. Just don't install this on a compromised computer or one that you think is compromised. Maybe a clean installation of your operating system or something, but always be on the lookout. And don't assume just because you have antivirus software or whatever that you're going to be safe, because most likely there's gonna be some issue. So thank you very much for sticking around for about 50 minutes in which I talked to myself, and there was another 20 before this in which I could not be heard. I hope that you liked this. I hope that you're gonna subscribe for more content like this, more cool Bitcoin stuff, more cool Bitcoin. And yeah, what can I say? Check out the Bitcoin Takeover podcast. I have so many cool guests that are already present there and many more whose interviews I still need to edit and put together for a proper production. And what else? You should also download the free and open source Bitcoin Takeover magazine, which is down there in the description of this video. And you can print your own. You can do whatever you want with that magazine. It's actually very cool. And this was it. Thank you, and I'll see you next time with some more cool Bitcoin.